Welcome. Today we will start our third project, which is 4-in-a-row game played against a computer. So let's remember the 4-in-a-row game. In 4-in-a-row game, the aim is actually there is a board, and the board is usually 7 columns and 6 rows. In our case, we will do a general 4-in-a-row game, so the number of rows and columns can be different. And the players actually play by dropping the coins from each column. So there are actually at most 7 possible, if we have 7 columns, 7 possible plays for each player. And if a column is full, which means in each row there are, for example, 6 coins, then the player should play other columns. And the point is, if a player generates a row or a row of coins of 4 in column wise, row wise, or diagonal wise, then that player wins the game. Okay, so that's actually the generic rules of the game. And since we already have done one game in our first project, so we can actually start and go a little bit faster. So first of all, there are 2 players, and the players will be in different colors. So which means we can, for example, add an enumerated class just by starting. So let's give a color as a class, and the colors are, let's say, blue, yellow, and empty. Okay, so this will actually show each, let's say, each cell of the board. If if that cell is blue, it means the blue player has a coin at that place, yellow for the second player, and empty, there is nothing on the board. Okay, so that's actually the color class. Okay, then we have actually the one coin class, which, let's say, we have a coin class, and the coin should only have so let's give not the name coin, but maybe stone or piece, let's say. Let's give a name of piece. So let's rename the coin with refactor, rename piece, refactor it, and give a name piece. And the piece should only have a color. So in that case, that's actually the color of the piece. Maybe we may have later some extra functions, but for now we don't have to have. So create a constructor, basic constructor, which actually sets the color, and let's generate a getter method for the color to have get color. Okay, so we have color for the piece, and that's actually done. So that's actually one piece, and then we can have actually the board. So the board actually represents the current situation of the pieces. So in that case, let's start with the first private piece array, piece double array, and we have actually the board here. So, and also we may have a row count and column count as the parameters, which can actually be taken from the board method, but overall we will do that as in a constructor. So public board, so integer row count and integer column count. And we initialize, so for each board, so let's initialize board. First of all, initialize row count. Row count equals row count, and column count equals column count. And then let's initialize the board. So board equals new piece. And then we have number of rows and number of columns. So that's initialization of the board, but that only initializes the piece, the board, but not actually the pieces. So let's also initialize the pieces. So row count I plus plus, and for integer j equals 0, j less than call count, j plus plus. So we initialize the board for each element. Actually, we will have new piece empty. So that's actually initialization of the board. We may, in that case, get row count and column count. So let's generate getters for row count and column count. This should be available. So, and other than that, maybe let's say we want to drop something on some column, and in that case, we need to know if that column is empty. So in that case, let's say column no. So in that case, which column? So in that case, we should check if the last board, so okay, let's do not write it now, and then write return true first of all. Let's make it empty, it doesn't matter. And then we may also play, because place in a specific column. So in that case, play in a specific column, and also with a specific color. So which will actually put the piece to the last available row. So in this case, the rows start from bottom. So the 0th row is at the bottom and the top row is there. And let's also give a standard constructor. So which actually this with 6 rows and 7 columns. So default is actually the 6 rows and 7 columns. And other than that, we may write some functions, which, for example, can check if the board is actually something like that. And we also need to print the board that will be available. So print the board means we will print the board, and then so that the player can see what is going on with the board. Okay, so these are actually the functions which came to our mind when we have a board. So there can be some functions about the evaluation of the board. So evaluation of the board means, for example, how do we evaluate a board? So if there is 3 in a row, 4 in a row, for a specific, let's say, the board. So in that case, let's, for example, write a function, public boolean, actually not boolean, maybe public color, 4 in a row. So the function will return if there is 4 in a row in the board, which could be then give us the winner of the game. Or we can also count 3 in a rows in the board for a specific color. so which gives us some information about the performance of the board. So for example, if you have a 3 in a row, then you should be careful that the player should play at that position. So that's actually 3 in a row, and maybe you can count 2 in a row if possible. Let's say 2 in a row, again, like if we think about it as an evaluation. Okay, so let's make them return 0, or okay, let's do not do anything. So 4 in a row checks if there are 4 pieces in a row, 3 in a row checks if there are 3 pieces in a row, or how many actually, and 2 in a row the similarly. Okay, so these are actually the functions, possible functions that came to our mind for the board. So we have some errors, but it doesn't matter. For now, we will fill them later because this is actually the design phase. So we have the board. So we have the board, we have the piece, and which is connected actually the color. Okay, so let's continue then with the players. So the board is the board object. So let's have a player object similar to actually what we have done in our first project. So let's create an abstract class player. So abstract class player, remember, we usually have 2 players, which is actually the human player and computer player. So for that reason, let's protect it, string name of the player and also color of the player. So given the name of the player and color of the player. So let's also construct a player with a specific name and with a specific color. Okay, so this name equals name and this color equals color. And we may need the name and color of the player. Let's generate the name and player of the colors, getters. Maybe we may not use them, but let's for now generate them. And then, as you see, they are not used yet. And let's see also the human player and computer player. So in that case, we have a computer player and which extends actually the player, and which should where we have a constructor matching super, and we also have a human player, which again extends the player. So extends player, and again let's create a constructor matching super. Okay, so then we also, okay, so the player, what should a player do? A player should play actually. So in that case, that function should be implemented by any method. So in that case, let's create a public abstract. And what should a player do? A player should actually choose a column to play, because the player can choose only the column. So in that case, we can return column as an integer. So play with S. So the player should know the board. So in that case, let's give it the board information. So in that case, okay, no, this is not be given in the human player, but player. Okay. So let's put it here. So in that case, let's implement that method in human player. As you see, the human player will choose actually which column to play. And the computer player should also implement the method, which actually will decide according to the board. Okay, so the player will decide so the player plays with the board, computer player plays, and then that's all for the player. Okay, so we have the board, we have the players, human player, computer player, And then let's see, we should have some kind of state of the game. So state of the game. So let's think about now okay, let's first think about the game. So the game should be played. So in that case, let's design a game class, which is actually coordinating all the game. So in that case, we have players. So player 1 and player 2. There will be 2 players, and we also have actually the board of the game, which actually changes according after each play, let's say. So let's create a constructor of the game. So the constructor of the game should have what? Should have the number of rows and number of columns. So it should initialize the board. So let's initialize the board equals new board with the row count and column count. And then also initializes the players. So which we take. Okay, so that's actually not written yet. And then we also need a public function, which is actually playing the game. So the playing of the game should be called from the game, and it directly organizes the whole game. So maybe we can write it play game or gameplay, something like that. Okay, so that's actually the play. So what will we do in play? So we start from the first player, and then first player could be a human player, it doesn't matter, or computer player. We will call the play of that, and then we will call the play of computer player, and we will continue until when? Until the play is over. So how do we understand play is over, game is over? We need to check actually from the board. So in that case, we need to check if the game is over or not from the board. So game over. So if the game over, then the function, the game will return. So if the game is over, then who will win actually? There can be 3 possibilities. The first player may win, the second player may win, or in that case, there will be a draw. So in that case, we should also check if the board is full or not. So if there is, so if all the, if there is an row or full of the board, then the game is over. So the game over may decide actually the winner of the game. So that could be also a possibility. So let's say we have game over, but in the game over, no, it's not possible, because how will we decide the 4 alternatives? So there is the draw, there is the 1 player wins, and the player continues. So game over in that case. Okay, so the board also should check the winner. So in that case, we can decide the winner, winner of game. So it will return the winner of the game as a color for the board. Okay, so that's actually for play. And we will also print the board each time, which is given in the print function. So other than that, so let's continue with the what? With board is empty, board is finished, game is finished. We have board, we have computer player. Let's now concentrate on the actually the computer player's play. So the computer player, or actually let's write the main first. Let's write the main first. The main should have public static void main and string args, and then it will create a game. So new game, which it should actually check the number of rows and number of columns. So you get number of rows and number of columns. Maybe in that case, we can create this. Let's take that number of rows and number of columns from the user here, and then gameplay. Okay, so that's actually the main function. So in the game, you should get the number of rows and number of columns, initialize the board, create players, and that's all. Okay, so that's actually the main of the game. So there, you can put that in the game or main, it doesn't matter. So now let's think about how the computer player plays. So the computer player actually tries to create all possible moves for a given board for itself. And then for each of that, it will generate possible moves for the opponent. And then for each that, it will generate possible moves for itself. And it will continue like that as a tree. So in that case, we can actually create a current situation, something like that. And then it will actually have a board. So in that case, we can have a state class, which actually shows the state of a current situation. So the state should have actually the board, current board, and it should create, so let's say, a board with its current board, let's say. So current, or let's give current board, or this board actually is current board. And then that's actually all. So it should have actually an array of children, possible of plays, possible of moves, let's say. So in that case, we have an array list of states as next states, which should be actually generated by a function. So it will create next states, so which we will actually write a function, generate next move, or generate tree of moves, which actually calls itself for each state. And the thing is, we should put a level to that because it will be then infinite. So then that's actually max level. So if we do one level, for example, we only generate one level for the next move. If we do two, then you have two level, three, then three level, etc., etc. So we'll generate all possible moves, and then we can evaluate actually the state. So let's do also an evaluation. And in the evaluation, we can have multiple evaluations. So in that case, let's do an evaluation function type, which could be again an enumerated evaluation function type. So let's create two functions, which is simple evaluation and complex evaluation. So we can have simple evaluation where you only check you win or lose, or there is nothing. It's something like draw. And we have a complex evaluation where we may calculate number of threes in a row and twos in a row and use that to calculate a value for that board. And these evaluation functions actually should be interfaces could be interfaces, let's say. So evaluation function. So evaluation function will be an interface, and it should actually evaluate a board. So integer evaluate, and it should evaluate a board. So it will evaluate a board and returns, let's say, a value. So, and there will be two evaluation functions. One simple evaluation function, which maybe checks, as I've said, if you have a winning situation or not. So simple evaluation function implements evaluation function. So in that case, implement the method. So it will implement evaluation. And then we also have the complex evaluation function, which actually complex evaluation function, which again implements evaluation function. So which will return a complex value depending on number of threes in a row and twos in a row, etc., etc. Okay, so these are simplex and complex evaluation functions. So other than that, we don't have anymore. So we have all things, hopefully. So we will see how we will evaluate them in the next hour. So we have the main, which calls the game, and then in the game, we will take input from how many rows and how many columns will be. And then we may assume that human will be the first player. And then we create the players, and then that's it. So in the play will start and do first the human player plays, then the computer plays, human player plays, computer player plays. Each time we check if there is a win or losing situation from the board. If it is not, then that's it. So for the computer player, we actually ask which column it should play. And in that case, maybe we can check if that column is full or not in the board. So in that case, we can write, so is empty. So is empty or is full. So if it is empty actually is full. Let's write is full, so that if it is full, it cannot play to that column. So the human player plays to a column. If that column is full, then it cannot play, and then we will ask again. And for the computer player, we actually have a method play where we actually start generating states from the current board. So the states are here. So we first create the initial state, root state, and then we will create next states by the generate tree of moves. And we decide also the level of the player. So in that case, maybe we should also put a level here. Integer level. So in that case, let's put a level here so that we can utilize this level in the constructing the states here in play. Okay, so states will be generated, and then that's all. So then, and so you should evaluate the actually the states. So in that case, generate tree of moves, and then, so what should we do? So we should actually get best move. So in that case, we may write integer get public int get best move. Given the states, we get the best move and play that best move. Okay, so that's all for today.